Hi guys, so we're going to do the second part of our A2 revision video, which means we're starting on question 9. Remember, best thing to do is to have a go at these questions and then listen through it. So pause it at the start of each one, have a go, listen through afterwards. Right, so we've got 2 cos 2 theta is equal to 1 minus 2 sine theta, and we want to solve that between 0 and 360. Now what we want to do is, because we've got a 2 theta in there, we're going to use the cos 2a formula, and that gives me 3 options. I've either got 2 cos squared minus 1, 1 minus 2 sine squared, or cos squared minus sine squared. Ideally we want everything in terms of the same identity, so I'm going to use the 1 minus 2 sine squared identity. So I can say 2 lots of 1 minus 2 sine squared theta. And I've still got this side as it is. That way you can see by expanding this, I'm going to end up with a quadratic in terms of sine that I can solve. So expanding this side gives me that one. Because I want my sine squared term to be positive, I'm going to move everything from this side onto this side. So I'd get a positive 4 sine squared theta. I've still got minus 2 sine theta. And if I subtract 2, I've got minus 1 equals 0. So I've ended up with a quadratic equal to 0. Now, with the quadratics, like I've said before, if you find it easier to say something like let x equal sine theta, then you can think of it as 4x squared minus 2x minus 1 equals 0. That makes it easier to just see that you are just dealing with a normal quadratic. There's nothing wrong with doing that. Now, in this case, what you've ended up with is a quadratic that doesn't factorise, so you're going to have to use the quadratic formula. So in our case, sine theta, or x, whichever way you've written it, is equal to minus b, so that's just 2, plus or minus the square root of b squared minus 4ac all over 2a. Chuck that in your calculator and you are going to get, give me a second. Right, so I've got I've got 1 plus root 5 over 4, and I'm guessing the other one is just going to be 1 minus. Yeah, 1 minus. So you've got 2 results. Sine theta equals 1 plus root 5 over 4, and sine theta equals 1 minus root 5 over 4. Now remember, this time we're solving between 0 and 360, which means you do need to make sure that your calculator is in degrees. And if we do sine to the minus 1 of the positive one, we're going to get theta is 54 degrees. If I do sine to the minus 1 of the negative, I'm going to get minus 18 degrees. From there, it's up to you if you use the cast diagram or if you're using the graphs as to finding the other results. So because we're going between 0 and 360, I've got 90, 180, 270, 360. So 54 degrees means there's another result there. So I just need to do 180 minus 54. That's going to leave us 126. And then the minus 18 is currently outside of our region, but we just use it to find that value and that value. So I need to do 180 plus 18, so that's 198 degrees. And I need to do 360 minus 18, gives me 342 degrees. And then this one is no longer valid because we are only looking at the values that fall between 0 and 360. And that's it. We've solved our equation. Right, if we then move on to question 10. Alright, so quite a lot in question 10. Make sure that you have a good read through everything that's going on here and be careful to take note of things like what temperature is measured in, what time is measured in, because there's usually somewhere that can sort of trip you up a little bit with these questions. but we're given initially that the temperature in degrees Celsius is 20 plus AE to the minus KT, where T is the time in minutes. Okay, given that the initial temperature, so if it's initial temperature, we know that's time 0. Initial temperature theta is 90 degrees Celsius. We want to find the value of A, so I'm just going to plug these two in so that I can work out what A is. So I get 90 is 20 plus AE to the 0. That's obviously just anything to the power of 0 is 1. So if I subtract 20 from both sides, I get A is just equal to 70. For part B, it says the T takes 5 minutes to decrease in temperature from 90 to 55. So we know at time 5, the theta is 55. We want to show that K is equal to a fifth ln 2. So all I'm going to do is chuck these values into here. So I get 55 is equal to 20 plus, we now know that A is 70, so 70 E to the minus, and since T is 5K. All we're going to do is we're going to solve to work out what K equals. So if I subtract 20, I get 35 is 70 E to the minus 5. If I divide by 70, I get a half is equal to E to the minus 5K. If we take ln of both sides, I get ln of a half is equal to minus 5k. Now remember what we said before, ln of a half I can treat, if I do this over here, I can say ln of a half is the same as 2 to the power of minus 1, which means I can write that as minus ln 2. So minus ln 2 is equal to minus 5k. Minuses then just cancel, so ln 2 is equal to 5k, and if I divide by 5, I can write k as 1/5 ln 2, which is what they asked for in the question. Right, and part C, find the rate at which the temperature of the T is decreasing at the instance when T equals 10. So because they've said the rate at which it's decreasing, remember rate is always differentiation, so we essentially need to find d theta by dt at the point when T equals 10, so we'll come back to that in a second. So for part C, we're going to differentiate. I'm just going to rewrite theta at the top there. So differentiating, 20 just disappears. This one, the minus at 1/5 ln 2 is just a number. So when you differentiate, that's your constant. So we know e to the a x, you bring the a in front. So we're bringing the minus 1/5 ln 2 in front. So you're going to do 70 times by minus 1/5 ln 2 e, and remember the power doesn't change, minus 1/5 ln 2. That means if I do 70 times 1/5, I'm going to get 14. So I've got minus 14 ln 2 e to the minus 1/5 t ln 2. We're not going to worry about tidying it up more than that, because all we're actually interested in is what the value is when t is 10. So at t equals 10, you get d theta by dt is equal to minus 14 ln 2 e. If you do minus 1/5 of 10, you just get minus 2 ln 2. So does it say in, no, it just wants 3 decimal places, so you're literally going to chuck that in a calculator. Minus 14 ln 2 times by e to the power of minus 2 ln 2. You get minus 2.426 to 3 decimal places. That means it's decreasing by 2.426 degrees Celsius per minute, because don't forget this is the rate of change of temperature over time. Okay, so it's changing 2.426 degrees Celsius and it's decreasing because it's negative per minute. And that's it. question 10 done. Right, question 11 is another slightly awkward looking one, but is not as bad as you think. So question 11, we've got the function f of x is equal to 8 minus x ln x. It's cutting the x-axis at points A and B, and the first thing they want us to do is write down the coordinates of A and B. So we know that if any curve is cutting the x-axis, then we know y equals 0. So we're essentially putting our equation equal to 0. That means either 8 minus x equals 0, in which case x is equal to 8, or ln x is equal to 0, in which case x has to equal 1, because ln 1 is 0. Okay, you could always do, if you weren't sure about that, if you've got ln x equals 0, take e of both sides, you get x equals e to the 0, which is 1. That means that my coordinate, A is obviously the first one, so the coordinate of A is 1, 0, the coordinate of B is 8, 0. Right, part B is we want to find f dash of x, so we want to differentiate. Now remember, if you've got the original function, okay, you've got two functions being multiplied together, which means if you're going to differentiate, you're going to be using the product rule. So u is 8 minus x, v is ln x. So if we differentiate u, I just get minus 1. If I differentiate v, I get 1 over x. So f dash of x is v du dx, so I've got minus ln x plus u dv dx, which is just 8 minus x over x. And that's it. I've got my I've got my differential function. We want to show that the x coordinate of q lies between 3.5 and 3.6. So if we just look back at our graph for a minute, if I want to find the x coordinate of this point, remember that point there would be a stationary point. We know for any stationary point, the gradient has to equal 0. So if we plug in 3.5 and 3.6 into here, so f dash of 3.5, so you get minus ln of 3.5, 8 minus 3.5 over 3.5, and then you're going to do exactly the same with 3.6. And the idea being, because we know it's a stationary point, we're looking for that to equal 0. Okay, which means if I'm looking for that to equal 0, I should end up with one positive number and one negative number. So if we plug in the 3.5, you're going to end up with 0.03295 and so on. If I do the same with 3.6, you're going to get minus 0.05871. And then just remember, as with any of these questions, you need to state why that is showing what you mean. So you're just going to put change in sign, therefore x coordinate of q lies between 3.5 and 3.6. Okay, so you want it nice and straightforward, as obvious as possible, but that is one mark out of any question, is that statement at the end, so make sure that that's there. Right, next part of this question, you've got show that the x coordinate can be written like that. So if we start with the fact that we have the equation 8 minus x over x, sorry, that was supposed to be a minus ln x, and we're saying that that is equal to 0. So this was our gradient function equal to 0. We're showing that the x coordinate of the solution can be written like this. So basically, I want to make one of these x's the subject, so I end up like this. Because I've got the ln x, I know it's not this one I'm trying to make the subject. Okay, so if I take that to the other side, 8 minus x over x equals ln x. If I multiply up, I get 8 minus x equals x ln x. you can see if the 8's going to be on the top and everything's positive, I need to bring the x across. So I've got 8 equals x plus x ln x, in which case you can factorise it out. And so 8 over 1 plus ln x gives us our x value. So you've shown that that's a possible solution if we rearrange for that x. It's then got question E. You're then going to use that rearrangement that we've just worked out, taking x0 as 3.55. We're going to find x1, x2 and x3. Let me just zoom in a little bit. Remember what I said about how you set these up? So always type in your first x value that you're given. So we're given x0 is 3.55. And if you set your calculator up right in the first place, so 3.55 equals, so it's in the memory of your calculator. Okay, and we're just going to set this up as 8 over 1 plus ln of the answer. It means all you need to do is keep clicking equals. So the first one, we're given to 3 decimal places, so 3.529, click equals again. Next one is 3.538, and next one, x3 is 3.534, and it's as straightforward as that. That should hopefully be a nice easy 3 marks to pick up in any exam. Right, question 12. Right, first thing straight off, this f double dot x and then the arrow is just a really awkward way of writing f of x. Okay, it's exactly the same as saying f of x equals this function. We want to find f to the minus 1. Now be very careful not to confuse the two things. Remember, f dash of x is your differential, f to the minus 1 of x is the inverse function. So in this case it's the inverse. So we write y equals 3 minus 2x over x minus 5. Now it's up to you if you swap the letters now or swap them at the end. Okay, I'm going to make x the subject first and then swap them at the end. So if I multiply up, I get xy minus 5y equals 3 minus 2x. I'm going to bring all the x's to one side and anything without to the other. So xy plus 2x equals 3 plus 5y. So I've brought this one to this side and this one to this side. That means I can factorise the x out and divide by that bracket to give me 3 plus 5y over y plus 2. Don't forget to write that as your actual inverse function. So f to the minus 1 of x is now you switch the letters back. So 3 plus 5x over x plus 2. And that's it. You've got your inverse function. Okay, it's just switch letters and rearrange. Okay, next one. I'm going to try and keep this on the screen if I can. So, you've got function g is drawn for us. It goes between minus 1 and 8. That's why the graph stops where it does. Okay, we want to write down the range of g. Remember, range is your y values. So that means that your y values, or g of x, has to be less than or equal to 4, but greater than or equal to minus 9. Now, the reason I'm including it is because if you look at your domain, you are including your value for minus 1 and for 8. So we are including the values they actually give. Right, second part is we want to find g of 2. So what that means is we find, if I put square brackets in there, you're going to find g of 2 first. So we go to 2 on the x-axis. The value it gives us is 0 for our y value. So this is then the same as us finding g of 0. So if you find 0 on the x-axis, the value it gives us is minus 6. So g of 0 is minus 6. And that's it. That's our answer. Okay, last one is fg of 8. So a lot of different things going on here. So fg of 8 means, first of all, we need to find g of 8. So again, x-axis, find 8. The result we've got is a y value of 4. So g of 8 just equals 4. So that then means I'm doing f of 4. which means I go back to my original function. I've got 3 minus 2 lots of 4 over 4 minus 5. So I've got 3 take away 8 is minus 5, 4 take away 5 is minus 1, 5 divided by 1, I get 5 as my fg of 8 function. Okay, next one. Are we still on this question? We really are. Right, okay. So this one's a bit of a long question. You've got part E. We want to draw on separate diagrams these two graphs. Now remember, the modulus sign means that at no point can your graph go negative. Okay, because I've not got anything extra outside moving it up or down. It is just anywhere originally the graph went negative, we're going to make it positive again. So we know the graph goes from 2 to 8, so I know that value there's 4. Okay, and be careful because all the numbers are there. You do need to be a little bit more accurate with the way you're drawing this. And then we know the original line on our graph that goes through minus 6 now needs flipping up, so it should go through positive 6. Okay, so that point there would be positive 6, and you know that point stops at 9 and at minus 1. So just be careful, you still are only drawing the part of the graph that you were given. You've not gone further in either direction than what you were originally given. That is our g of x, taking the modulus. Second one is the inverse function. Now remember, an inverse function is just a reflection in the line y equals x. So the best way to do this is actually looking at your original graph. You're just going to flip everything around. So instead of being 8, 4 as that coordinate, it's now going to be 4, 8. Okay, so that highest point there is now going to be 8. That point there is now going to be 4. Okay, instead of the point 2, 0, it's now going to be 0, 2. So I know my line's going to look something like that. Okay, and then the point down here where it crossed the y-axis, it crossed at minus 6, so it's now going to cross the x-axis at minus 6. And then where it used to finish on at minus 9, it's now going to finish minus 9 that way and only minus 1 down, so it's going to finish there, which means you're going to get a line that looks like that. So I've got my inverse function is just a reflection in the line y equals x. Okay, and then last bit, state the domain of the inverse function. Remember, the domain of the inverse function is the same as the range of the original function. You just have to write x instead of g of x. So it's x is between 4 and minus 9 because it now goes between minus 9 and 4. Okay, now I put this one in, or rather I left this one in. This is one that you have now seen 2 or 3 times. Okay, just because I know we were still making mistakes on it. I wanted to make sure that we got it perfect this time round. So remember, you've got something written in a fraction form that we need to differentiate. So in fraction form, if you're differentiating, it's a quotient rule. So u is written as 3 plus sine 2x. V is written as 2 plus cos 2x. That means if you differentiate sine, you're going to get cos. The extra factor of 2 goes in front, so I've got 2 cos 2x. If you differentiate cos, you get minus sine. The extra factor of 2 goes in front. Okay, so I've differentiated my functions. We're then going to apply that into the quotient rule. So just be careful to get this the right way around. V du dx. So I've got 2 cos 2x times by 2 plus cos 2x minus u dv dx. So I've got 3 plus sine 2x times by minus 2 sine 2x all over, and then v squared, so 2 plus cos 2x all squared. So remember, there's a lot going on in this question. Just multiply it out carefully and be very careful with your minuses. So on the top, I'd get 4 cos 2x plus 2 cos squared 2x from these first two brackets. This one, because I'm multiplying this bracket by everything inside here, it means everything inside here is going to become negative, and then the minus outside is going to make it positive. So basically that minus and that minus cancel each other out. So 3 times 2 sine x is 6 sine 2x. And then sine 2x times 2 sine 2x is 2 sine squared 2x. And I missed the squared off there, didn't I? Okay, all over. And the bottom stays as it is. Please, especially in these show that questions, don't skip steps. I know it's annoying to keep writing out the fraction every time, but there are a couple of people who keep leaving the fraction out, dealing with all the top and then putting it back at the end. It loses marks. Okay, if you make a mistake anywhere because you haven't shown the fraction all the way through, you lose all your marks. So on this one, we know that 2 cos squared plus 2 sine squared, so I'm just going to write this over here, 2 sine squared 2x plus 2 cos squared 2x, that's just 2 lots of sine squared plus cos squared, and we know sine squared plus cos squared is 1, so I get 2 lots of 1 is just 2. So I can make the top of this fraction 4 cos 2x plus 6 sine 2x, and these two disappear to just become 2 all over the bottom, which is exactly what they wanted us to show. Next part is we want to find the equation of the tangent at the point where x equals pi by 2. So a few different things we need to work out. So at x equals pi by 2, remember this puts us back in radians. So the last thing we did on our calculator was in degrees. So we're going to shift back again. Right, you need two things. You need to find your y value, and then you need to find your dy by dx, so that you've got your coordinate and you've got your gradient. So when x equals pi by 2, I've lost my actual question. Y was this one, so I'm going to do 3 plus sine, and 2 times pi over 2 is obviously just pi, over 2 plus cos, and again that's just pi. That's going to give me 3, so my y coordinate is 3, so I know it's pi by 2 and 3. And then dy by dx, we're just going to chuck pi by 2 into this entire mess we've got at the top there. So 4 cos pi plus 6 sine pi plus 2 over 2 plus cos pi all squared. You're going to get minus 2. So that's the gradient of my tangent. There's my point. I'm going to find the equation of the line. Y minus 3 is minus 2 lots of x minus pi by 2. So expanding the right hand side, you get minus 2x plus pi, and then all I'm going to do is add the 3. I get minus 2x plus pi plus 3, and that's it, you're done. All right, I think we're coming on to the last few questions. So question 14, a little bit of a weird way that they write things in this one. It's not a usual way that you'll have seen stuff. This just means the differential of cos x. So they've replaced the y in dy by dx with what you're actually differentiating. Okay, so the differential of cos is minus sine. They want you to use that fact to show that the differential of sec is sec x tan x. Okay, so first thing we need to know is that sec x is the same as 1 over cos x. So if we're going to differentiate 1 over cos x, we're going to use the quotient rule. U is 1, v is cos. So I get du dx is 0. That means that dv by dx, it already told us in the question, is minus sine x. And then we're just going to apply the quotient rule. So dy by dx is v du dx, so that's 0, minus u dv dx over v squared So I end up with sine x over cos squared x. Now they want us to show that that is the same as sec x tan x. Well, sec is 1 over cos x, and tan x is sine x over cos x, which is just how I could split this fraction. I could treat it as 1 over cos times sine over cos, in which case you've got sec x tan x. Okay, that one you should be pretty familiar with. It's how we introduced the differential of sec when we first started. Right, part B, you're given this time x equals sec 2y. And they want us to find dx by dy. It is quite common to get a question like this towards the end of a paper. It is the little bit more challenging one. This first bit's not too bad. It's what happens next. So we know that if we differentiate sec, you get sec x tan x. So in this case, I'm going to get sec 2y tan 2y. And then the extra factor of 2 you've got goes in front. So it's 2 sec 2y tan 2y. Right, that bit hopefully nice and straightforward. This one a little bit trickier. You want dy by dx. So if this is dx by dy, then dy by dx is 1 over that answer. But they want it in terms of x. So we need to eliminate the two y terms. Now, this first one, I know that sec 2y is just x. So I can replace that with x. That bit's nice and easy to deal with. The second bit is a little bit trickier. So if I use this equation, if I know x is equal to sec 2y, that was supposed to be a 2, then if I square both sides, x squared is equal to sec squared 2y. The reason for that is I know from my identities that my squared identities in particular, that tan squared x or tan squared, I'll write it in 2y form, plus 1 would be equal to sec squared 2y. So that means I can say x squared is actually equal to tan squared 2y plus 1. And so I can say tan squared 2y is x squared minus 1. And then if I square root both sides, I get tan 2y is the square root of x squared minus 1. But it does mean I've now got a way of replacing, tan 2y with what we know it's equal to. So I can rewrite dy by dx as 1 over sec 2y, we said is just x from the top of our question. So I've got 2x, and then tan 2y is this horrible mess here. So I've got the square root of x squared minus 1. So doesn't look pretty and never will in these questions, but you've got dy by dx in terms of x. All right, so that's up to question 14. So we've got our last two questions. These ones hopefully should be a little bit quicker. Right, question 15. You've got a sequence where you're told a1 is equal to 2 and an plus 1 is equal to 3an minus c. We want to find an expression for a2 in terms of c. So just remember, this stands for the next term in the sequence is 3 lots of the current term, take away c. So I've got 3 lots of the current term, take away c. I can write that as 6 minus c. And that's it. I've got my expression, part A done. Part B then says, given that the sum from 1 to 3 of ai is equal to 0. So this means sum from 1 to 3 of ai equals 0. So it basically means if you do a1 plus a2 plus a3, it should equal 0. Now a1 we know is 2. a2 we know is 6 minus c. But before I can do this, I need to work out what a3 is. So I'm just going to work that out on the side of the page. So a3, using our formula at the top again, to get a3, I'd need 3 lots of a2 minus c. So I need 3 lots of my a2 value minus c. So I get 18 minus 3c minus another c. So I get 18 minus 4c. I'm now going to add all my numbers together. So a1 is 2, A2 is 6 minus C, A3 is 18 minus 4C, and that has to equal 0. In which case, I've got 2, 8, 26 minus 5C equals 0. So 26 is equal to 5C, in which case C is equal to 26 fifths, or 5.2, whichever way you've written it. And that's it, question 15 done. Okay, if we look at question 16. Right, arithmetic sequence, so this is sequences where they're adding on every time, has a first term of A and a common difference of D, so that's pretty standard. It says the sum of the first 10 terms, so S10 is 162. So we're given first term is A, common difference is D, and that the sum of the first 10 terms is 162. We want to show that term. So we want to show 10A plus 45D equals 162. So your sum formula is n over 2, 2A plus n minus 1D. So all we're going to do is chuck in our numbers. I know the sum to 10 is 162. Because it's the sum to 10, I've got 10 over 2 is 5, lots of 2A plus 10 minus 1 is 9, so 9D. So I've just chucked in basically that our n value is 10 and our answer should be 162. So I get 162 is 10A plus 45D, which I believe is what they asked us to prove. Yep. Right, then you're given a bit more information. We're told for part B that the sixth term, so U6, is 17. We want a second equation. So U6, remember, that's your nth term rule. And the nth term rule in general for any arithmetic sequence is A plus n minus 1D. So we're going to put 17 is equal to A plus 6 minus 1 is 5, so 5D. And that's it, second equation. All they want you to do is then find A and D. Well, you've got a very standard set of simultaneous equations. So if I times this bottom row by 10, I get 170 is 10A plus 50D. The top equation was 162 was 10A plus 45. And you've got a very straightforward solving equations question. I've got 8 equals 5D, in which case D is equal to 8 fifths. And then all we're going to do is plug that back into one of our equations. I'm going to use this one. So I get 17 equals A plus 5 lots of 8 fifths. So that is 17 equals A plus 8, since the fifths are just going to cancel out with a 5. So A must be 9. And that's it. You've got your value of A and you've got your value of D. Right guys, hopefully all of that was helpful. Let me know if you've still got any questions.